Hello. In this video, we'll be starting from the standard CODESYS project that we created in the last video, and we'll be adding a CAN bus to this project. So I have my CODESYS IDE open, and I'm going to go ahead and open the project that we were working with previously. So that is this training proj 1. Go ahead and open that. As always, may take a second to open. So we'll be going over how to add a CAN bus. In this video, we'll be adding a J1939 CAN bus, and in the next video or a separate video, we'll also add a CAN open CAN bus. Okay, so here we have our training project as we left it in the last video. So if you remember, we've updated the device description here to match the version of the runtime, and we've done nothing else. All right, so if we want to add a CAN bus to our project, we're going to right click on device and say add device here. So you'll see multiple devices listed here. So you have some miscellaneous devices and field bus devices. So a good thing to note is even though you see all of these devices listed here, it doesn't necessarily mean that the runtime on the display supports all devices. So for instance, like EtherCAT is not supported on the displays by default. So if you see something that is not just a normal field bus device like a CAN bus, and you are wondering if it's supported, feel free to email our support team and we can let you know. If it is not supported by default, you can work with us and CODESYS to enable that support within the runtime. Okay, so in this case, we're gonna select a CAN bus, and you'll see we have a NetX CAN bus and just a normal CAN bus. So we want the normal CAN bus. I'm gonna go ahead and delete this. Sorry. Let's add this. All right. So one other important note. So a lot of times, if you're using a version of the CAN bus here, so you see this, you're using a version that's higher than the version of the runtime on the display. I have run into issues before where the CAN bus just won't work. It doesn't receive values, but it will build and deploy successfully. So I would recommend trying to at least match this version with the version on the display, or at least get it close or under, preferably. So again, you see mine is defaulted to the highest version I have installed in my IDE, which is 3.5.7. But on the displays, we're using 3.5.4.2 runtime. So what I want to do is again click display all versions, and you'll see here I have 3.5.4, which is pretty close to 3.5.4.2, and it's a little under. So I'm going to go ahead and use that one. And then if we go ahead and then click the CAN bus, you'll see you have some different options here. So you have a CAN open, a device net, or a J1939. So by default, CAN open and J1939 are supported in the runtime. Again, in this video, we'll focus on J1939. In a future video, we'll talk about CAN open. So I'm going to expand this, and you'll see again my different versions are displayed. So I'm just going to match the version of the CAN bus I have running. So 3.5.4.0 again. I'm going to add a CAN manager. Then I'm going to come over here and click on the CAN manager, and we have a J1939 ECU. So I'm going to go ahead and add an ECU to that. Okay, so let's look at this one by one now. So if we go to the CAN bus, and double click it, we have our CAN bus settings. So the first one we get to is network. And this is looking at the physical CAN bus on the display. So it's a zero-based index. So network 0 correlates or refers to CAN bus 1 on the display. If we say network 1, that would be CAN bus 2. All of our displays have at least 2 CAN buses. Some have, 4. So, 0, 1, 2, or 3 would be usable for displays that have 4 CAN buses. Or 0 and 1 would be usable for displays with 2. The next one, we have our baud rate. So this is the speed at which data is transferred across the CAN bus. You should be at least a little familiar with the CAN bus in general for these videos. I'm not going to go into too much detail about the CAN bus, but there will be a video posted on general ideas behind the CAN bus, at least enough information to get you started. So if you're not familiar with the basics, please go watch that video. So most CAN buses, as we will discuss in that video, run at 250K baud. Occasionally you get some, at 125 or 5, and then at like the very top 1 meg, but we'll stick with 250K as that is a pretty standard speed for many CAN buses. Okay, so next we're going to go to the J1939 Manager, and here we can select the database that is used for J1939. So right now it's set to the default, which is perfect. And then finally we're going to look at the ECU. So in CODESYS, setting up a CAN bus is a little different than what you may logically think of it as. So even though we are setting up a program for the display, as we set up this ECU, we're not going to be setting this particular one up in the perspective of the display. So how you can think of this layout here is we are telling CODESYS all of the different ECUs on the bus, not just what you expect the display to receive, but every ECU that's on the bus. So in this case, we will make this ECU we'll change the name and call it engine. So it makes sense to us. So we have our engine ECU here, and that's what we're going to set up. So if we double click, we get to this general tab first, and up here is our preferred address. So this is referring to the source address of this ECU. So generally engine ECUs are by default source address 0. So we can keep it at source address 0. But if your engine ECU has another source address, say like source address 5, and this is in decimal, we'll need to change it to source address 5. So essentially you need to know your source address of the different ECUs on your bus and make sure they match up here. Local device we'll get to in a second, as we make another ECU in a sec. Okay, so if we go to TX signals, so these are the signals that the engine controller on the bus will transmit, TX, so send out, that we want the display to receive. So whatever you're building this program for, in this case we're building it for a display, we're telling it, okay, there is an engine ECU on the bus that we care about, we want to receive messages from it, and these are the messages it's going to send out that we want to receive. All right, so right now we have no messages set up, but if we click this add PG, we can set up some messages. So for instance, I can look at engine speed, and I happen to know the engine speed we're looking for is a 61444, but I can expand this So this is the PGN here, 61444, and then included in that PGN are these messages or signals with their SPN number. So engine speed, for instance, could be one of the messages we're interested in receiving. So in that case, we need to bring in this PGN. Again, if you're not familiar with PGNs, SPNs, how these messages are set up, please watch the video on basics of a J1939 CAN bus. So in this case, though, we're just going to say add PG. Okay, so we now have PG in here, and we'll bring one more in just for example purposes. So we'll say, okay, maybe we want to see the fuel level. So it's the fuel level shown in this one, but again, you can expand it, and that is the message we're interested in receiving. So we're just going to go ahead and bring this into. So now we've told our program the engine controller is going to be sending out two messages that we want to receive. Engine speed and fuel level is what we're interested in. But because they're sent out in a single PGN, we will receive all of the messages here, even if we don't care about them. Okay, so the first thing to note is we will receive these messages, and if we go to this J1939 Io Mapping, one of the really nice things about CODESYS is it brings in these signals and maps them to variables in your project automatically. So you don't need to do any work to get the values of these signals. Once they're received from the CAN bus, they're brought into CODESYS, and they're given variables which then you can use in your project to get the most up-to-date value being sent from the engine controller. So in this case, we're going to go ahead and expand. Take a look at these. So these are the variables that are set up in our project. So you'll see here we have a variable called engine speed and a variable called fuel level. But right now, if you look at the type and unit of these, they're in bytes of data, because that's how CODESYS receives the values in a raw data set from the CAN bus. It just receives bits, which it translates into bytes. So each of these is, you'll notice there's 2 bytes in engine speed, so it's a byte array in this case, and here we break it down into bits. So most of the time, bits and bytes are difficult to work with. You would have to convert them yourself in your project to get any meaningful data. But CODESYS provides an easy way for us to do that. So we're going to come back to this TX signals here, and we're going to say, look at engine speed. So right now, it's given to us as 16 bits, but we'll see over to the right here, on the bottom, you have information about the engine speed signal, the SPN, signal name. Here you have some description of it. So, it tells you what it actually is giving you, and the length in bits, the byte position within the PGN, and the bit position. So the starting byte and bit position. So this will show you how to index it if you wanted to just receive the whole PGN message. So up here is the more important part. So up here we have conversion, and you'll notice that all of the signals by default are converted or set at false to convert. So we actually want CODESYS to convert the signals we're interested in. So if you go click true here, you'll notice now it takes the J1939 presets or the definition for this signal. So in this signal, J1939, the database says, okay, the scaling of this is 0.125 with a 0 offset, and your value range is between 0 and 8031. And it's in units RPMs. So with this, now we actually have some data that we can work with. So as we convert these signals, we can actually get usable real data set in RPMs. So in a similar way to our fuel level is not converted. But if we set convert to true, now we have a value from 0 to 100%, which tells us the percentage full of our fuel tank. So again, scaling and offset, these are our standard J1939 CAN bus terms that you should know, even though CODESYS makes it easy to work with, that you don't necessarily need to know what these are. I would recommend at least having some knowledge behind it. So it'll make it easier if you need to send out and receive messages from different CAN buses, maybe that don't necessarily use CODESYS. So maybe another ECU on your network won't use CODESYS, and you need to know how to send that data out so it's received correctly within CODESYS. So I would check out, again, if you don't know what these are, check out the J1939 basics video. Okay, but now we have told CODESYS to convert these two signals. And if we come back to our Io mapping, we can see that that is done. So it's now changed the name of our variable to engine speed 1. If we wanted, we could change it back just to engine speed. But you'll notice here, we're now given a real value in RPMs. So this is a real is just a number value with some decimal points. And we're going to do the same thing for fuel levels. So just change that to fuel level 1. And we're given a real value in percent. We could change the signal name or the variable name here to anything we wanted to use in our project. If I just wanted to call it fuel level, I could change it to that. Obviously, you just have to make sure not to use the same variable name. I believe it may give you a warning if you do. No, it doesn't. So be careful not to use the same variable name in two of these, but as long as you use unique variable names, you can use any one you would like. Okay, so now we've created two variables, or essentially brought in some data from the CAN bus and linked them to variables in our project. And then in further videos, we'll be using those variables in our project to link to like gauges in our user interface, or bring into our program here so we can see, if I type in engine speed, you'll see that it is set up here, and so I can see it's a variable in the project, and I would, anytime I reference this variable, it would have the latest value of the engine speed signal that is sent from the engine ECU. Okay, we're going to do two other quick things. So let's say you want to add a message that is not a standard J1939 message. So here are all of our standard messages from the database. But let's say we want to add a custom message, or you have a custom message coming in from another ECU. So in this case, we're setting it up and saying this engine ECU is going to send a custom message. And what we're going to send is, we want to send, FF, we'll say, let's clear this out. Let's say we want to send FF 20 in hex. So that would be 65312. So we're going to say 65312. And there we go. So it breaks it down into the PDU specific, PDU format. So it sort of does this for you. You don't really need to do much about it. And here we give our PGN, our custom PGN, a name. So I'll just call this custom PGN. We tell it the length in bytes that we want it to be. So 8 bytes is a standard message. We'll keep it at that. The priority of the message, so it could be 0 through 6, maybe 7 actually, but we'll keep it at 3 or 4. And we can give it a description, so we can say, you know, just for our own information, custom PGN, and we'll say this includes temperature and, you know, something, anything else that we want to eventually add to it. So we're going to go ahead and add that PGN. So you'll see, okay, now we have a PGN added here, a custom one. But you'll notice in the messages above, if we expand it, they have signals associated with them. So in this one, we haven't added any signals yet. So now we need to go and say add signal to it. So the first thing that pops up is the database. So we can add our database-based signals. So if we wanted to, for instance, come up with a custom PGN that sent engine speed and sent fuel level and sent transmission oil pressure. So we could add all of these messages to this custom PGN, and it would then send those, or I guess this program would receive this custom PGN which contained all 3 of these messages. So sometimes you can have a custom PGN that you want to send or receive because you don't want to send 8 different PGNs to receive 8 messages, when you can just send a single PGN which contains all of the data you want to actually receive. So we could add, like we just did, signals from this database of standard J1939 signals. But there'll be times also when you want to send custom information that may not be included in the standard database. So here we can go custom, and we can give our custom message an SPN name. So I would say, you know, don't make it so it's not an SPN already in the message, but you don't need necessarily a unique SPN, but it shouldn't be one that you're already receiving, hopefully, from another message. So in this case, we'll just call this like custom signal. We can define our length in bits. So, you know, we'll say let's pretend this is going to send a temperature, and it's going to be an integer, and we want to send 0 to 100 values, so in integers. So I think we'll need around 7 bits of data. So 7 bits gives us 128 values. So we're going to say 7 bits, and we can give it a description. So we'll just say temperature ranges from 0 to 100. So here we can tell it whether we want to convert or not. So if we want to convert, we can check that. We can say, you know, Celsius. I don't know if that's just a C or if you need to put degree C, but and then our data type. So unsigned in this case is good. We don't need it to be a float or a double because we've said we're not gonna, it's just gonna be an integer, so we're not using decimal points or anything. Little Indian byte order is fine. If you don't know what that is, just a quick Google search should tell you. In this case, because we're not using the not using decimal points, we don't need to scale it. And since it's just 0 to 100 unsigned, we don't need any offset. So we can go ahead and add our custom signal here. And you'll notice that CODESYS, it changes our bit and byte positions as it should here. So this one is 16 bits and starts at byte 0, bit 0. Then this next one starts at byte 2 because this first message is taking up 2 bytes of our 8 bytes of data. So this we should expect to start at byte 3 here, and then this will start at byte 4. Okay, because this one only takes up 7 bits, we would expect the next message we add to start at byte 4, bit 7. And if you add another one, you'll see that. So here, we can build up our custom messages within J1939. Okay, and the last thing we'll do is add a local device. So if we wanted, many times, well, almost all the time, you're going to have more than one ECU on your CAN bus. It wouldn't be useful or make any sense if you only had one ECU. So okay, so we've shown how to set up a J1939 ECU. Now you'll notice right now we only have one ECU in our network. So that doesn't make a lot of sense. There's not really a purpose to only have one ECU in a CAN bus. So almost all the times you're going to want to add or have more than one ECU communicating. So if you want to add an additional ECU, we can right click and say add device and just select another ECU. So now a second one has been added. So we can double click this one and kind of go through the same steps we've done. So I can change this, for instance, to transmission if this was our transmission controller. The last thing we can do is add so right now we're setting up this project for a display. So if we want to set up the display on this network, what we're going to do is add an ECU and change the name to display ECU. And we set this up exactly like the other ECUs on the network, except we are going to change the device address. So let's say we wanted the source address of the display to be 28. So we'll change that. And we're going to click local device here. And this tells CODESYS that this device on the network is what is running, the program that's running on the actual device. So it tells CODESYS that the program is a local ECU. And now as we set up our TX messages here, these will be actually sent out from the display to the rest of the devices on the network. So this is our display, and we're now setting up, okay, here's the messages we want our display to send out to the transmission and engine controller. And just to avoid confusion too, so our engine controller was source address 0, our display is source address 28, our transmission controller is usually like source address 2 or 3. So it's important to make sure that each of your devices have a unique source address. But setting up messages for the display are the same as what we did for the engine ECU and transmission and everything else. Okay, this was a basic video about how to set up messages in CODESYS. Tune in for future videos on CAN Open, and if, for instance, you wanted another CAN bus, that's easy to do. So if you're using another CAN bus, you can add a second CAN bus to your network and go and add all of the devices on that CAN bus, just like we did before. And make sure, if this was confusing in any way, make sure to watch the basics of J1939 video. All right, thanks.